Hello everyone, welcome to eGita platform, and this is Robin Jangid here, your electrical faculty, and in this video I am going to talk about the fault producing overcurrents. So I have come up with the fault producing overcurrent which are classified into the three categories. Okay, so let's start one by one what the three categories are actually going to define here. Now let's start. So if we talk about the internal faults, if we are talking about the internal faults which cause the high overcurrents but are very infrequent, not in the frequent, not occurring in a consecutive manner. Okay, so which whenever there is a chances of the internal faults that in the walls, okay, so which causes actually the high overcurrents. So what will happen due to these internal faults? It will have the high overcurrents but are very infrequent. The thyristor surge current rating must be chosen to withstand these overcurrents. So as I have told you, that is internal faults whenever come in your mind, then you have to remember the simple thing that it is talking about the walls. Okay, so now the thyristor surge current rating, okay, for the protection for that, the internal fault, for the protection of that, it must be chosen to withstand these currents. Okay, if we have to withstand with these currents internal faults, then we have to use the surge current ratings. Now point number 2, line faults which cause the overcurrents in the range of the 2 to 3 per unit. So if you're talking about the line faults, the faults which are occurring in the HVDC lines, okay, which cause the overcurrents, if it is causing the overcurrents, then the overcurrent will be in the range of 2 to 3 per unit. And these are actually limited by the current control, that is the CC which we have talked about, okay, current control. And the protection against the line faults which are the frequent will be discussed in the next chapter, or it is written we will talk about the next chapter. Okay, now the commutation failure at the inverters may be the quite frequent. It may occur consecutive manner. If we talk about the commutation failure, so that commutation failure, and that is at the inverter side. But however, the overcurrents are actually the small and limited by the current control. The values for the overcurrent value, okay, the false overcurrent value is going to be very less. So these are not that much harmonious to your system, and that can easily be limited by the current control. However, because of the continuous conduction during the commutation failure, you know, and I have explained very well that whenever you have the commutation failure, then there is a transfer of the DC current from one wall to another wall. If it is belonging to the any particular portion, either positive commutation portion or the negative commutation portion, so that will be for that. So if there is a transfer of the currents between these walls, then it is talking about, then the current reference has to be reduced. Then whatever the current reference which we are taking, it or you can say the has to be reduced there. Now in case number 1, the normal operation may commence only after the inspections of the walls to check for the damage. In case number 2 and the 3, these are the case number 2 and the 3, the normal operation can commence soon after the fault clearing. Okay, so that is the simple thing which is written here. So I hope you have understood all the fault producing overcurrents classifications. Thank you so much.